Right, so here we go, Jacob. Maybe I can type on the chat and, or I can try text. So, okay, so y equals 0.25x plus 5. So that could be the first one. So we're gonna first enter the equations and then we decide about the subdomains. The other one, minus 0.3x plus 7. Okay, and the next one, 0.05x plus 1. And the last one, 0.65x minus 16. Okay, exactly. Beautiful. Looks super messy. A lot of lines there. So for the first subdomain, for the red one, let's write for this for x between 1 and 7. Great. Yeah. Excellent. So you can see the little red piece there. And then for the blue one, we can go for x between 7 and 15. Uh-huh. Yeah. And for the next one, we can go for x between 15 and 30. And the last one, we can go between 30 and 45. Right. So let's, can you, yeah, zoom in a little bit? This is where maybe we could do what Patrick was doing and play around, but I don't know. But this, the main thing is that you have 4 lines. The biggest of the slopes is the biggest value, the largest value. So you have values 0. All the 3 positive values are 0.25, 0.05, and 0.65, right? And so the values, the largest value of slope is the one that appears in purple, that one, the very last one. The second piece here, this piecewise linear function is blue, excuse me, and then that is negative 0.3. So if these were measuring or lining up with measurements of, excuse me, cases, then you are optimistic that it goes from the first interval into the second interval. There's a really sharp decline. So the number of cases is really going down on that interval 7 to 15. But then it goes, so it first has a positive rate of change, it switches to a negative rate of change, it switches into positive rate of change, but it's not as drastic in the green, the subinterval for the green line. The rate of change there is not as drastic as it was initially. However, on the fourth subdomain, the fourth interval, it becomes a lot larger than ever before, right? So that's the idea of relapse, is that things were allegedly under control, and then they go back to be not under control, and then be actually a lot worse than they were supposed to be. So that's what this is illustrating here. Okay, so thank you so much.